5. Find the prime factorization for the given number. 72 to the 100th power. Now wait a minute, isn't that just the answer? I mean, isn't that already the prime factorization? No, it's not. Why not? Why is that not the prime factorization? Do you see that? Is the 72 a prime number?
It could be broken down.
Right, we got to break down that 72, don't we? So we take the 72, we break it down, 9 times 8, 3 times 3, 2 times 4, 2 times 2. So in the end, we get 2 to the 3rd times 3 squared. Right, that's the breakdown of a 72. By the way, you know it doesn't matter how you do this, right? If I instead said, I'm going to go 2 times 36, and 6 times 6, and 2 times 3, 2 times 3, in the end, you're going to get 3 2s and 2 3s. Same thing, right? So it doesn't matter how you break down these numbers, as long as you just keep breaking them down, and you don't keep the 9 or the 8 or the 4 here, just like you don't keep the 36 or the 6s, right? Because they broke apart. Just the things that, just the final building blocks that don't break down any further, you'll get the same exact pattern, because there's only one way to make a 72. It's 3 2s and 2 3s. That's the prime factorization, the prime building blocks of a 72. Okay, so now let's answer this question. We're supposed to take 72 to the 100th power, right? 72 to the 100th power. But now we know that 72 is really 2 to the 3rd times 3 squared, isn't it? To the 100th power. So 72 to the 100th power means 2 to the 3rd times 3 squared to the 100th power. So what am I going to do with that 100th power? What is a 100th power? If I write x to the 100th power, or how about this? Rather than x, what if I write 2 to the 100th power? We know that means 2 times 2 times 2, blah, 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 100 times, right? We all know that. That's what a power means on something. It means 100 of those 2's multiplied together, right? So if I was to do that, I don't want to do that, of course, but if I was to say, well, this means 2 to the 3rd times 3 squared, and then another 2 to the 3rd times 3 squared, and then another 2 to the 3rd times 3 squared, dot, 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 100 times, right? That's what that means. It means 100 of those. So therefore, we have 2 to the 3rd 100 times. So how many 2's are we going to have all together? We have 3 2's, 3 2's, 3 2's, 100 times. So how many 2's? Uh, 300, right? If you have 3 2's 100 times, you have 300 2's, don't you? And if you have 2 3's 100 times, then you have 200 3's. So you just multiply those, and there it is. There's our answer. That's the prime factorization. There must be 300 2's and 200 3's in 72 to the 100th power. We just broke down the 72, 3 2's and 2 3's, and then 100, take that 100 times. There we go.